Hey class, today we're going to be going over section 2.5. This is going to be a section where we're learning how to solve problems, specifically word problems. And during this lecture, I'm only going to be doing examples. So please try to solve these examples on your own by pausing the video and then solving it and then pressing play once you're done. We're going to start off with a problem that tells you twice a number added to 7 is the same as 3 subtracted from the number. Find the number. So twice a number added to 7. Let's take that phrase first. Twice a number added to 7. So twice a number is what we're going to do first. 2 times x added to 7. So this comma basically tells you to just write twice a number alone and then add 7. If it would have said twice a number added to 7, would say something like 7 plus x, parentheses, times 2. So this is going to be 2x plus 7. Now, they have this phrase right here, is the same as. So this phrase is going to tell us to write down an equal sign. Once we do that, we can move on, and it says 3 subtracted from the number. So the number. So notice before it said a number, and then now it's saying the number. So this the is to suggest that it's the same number that we multiplied 2 by. So it's also going to be x. So 3 subtracted from the number. So this means that x minus 3. And now we can try to solve it using all of the methods we've talked about before. And the first thing we're going to do is we can move this x over, which gives us x plus 7 is equal to negative 3. And then we're going to subtract 7 on both sides. This gives us the solution that x is equal to negative 10. Okay, let's try another one. Okay, so here's another example that's trying to find the number. And this example is good because it kind of highlights what I was talking about the comma earlier. So the way this problem starts off is it says twice the sum of a number in 4. Notice that there's no comma anywhere in this sentence. So this suggests that the sum of a number and 4 is in parentheses, x plus 4, and the twice is outside of this parentheses, multiplying both x and 4. Now we see the same phrase is the same as, telling us to put an equal sign where we are. And then we have 4 times the number, comma, decreased by 12. So again, we have a phrase, 4 times the number, and then a comma. So this is going to tell us to write 4 times x first, and then decrease that by 12. So subtract 12. And again, like last time, we just use our rules that we talked about in the previous sections to simplify this. First, we want to distribute the 2 to get 2x plus 8. And then we want to subtract over our x's and our numbers, so that way we get the x on one side. So here we subtract 2x. And since we're moving x over to the right, we're gonna move this 12 over to the left. So we add 12 to both sides. When we do that, we see that we get 0x on the left plus 20 is equal to 2x on the right, and then we get plus 0. So it's 20 is equal to 2 times x. Now here, you can look at it like dividing both sides by 2 or multiplying both sides by the reciprocal of 2, which is 1/2. And our solution then, just writing it off to the right, is going to be x is equal to 20 divided by 2, which is 10. Okay, in this example, it may seem like we're trying to solve for 2 variables, but in fact we're only solving for 1. I'll let you pause the video and try to figure this out. Okay, so we have a 48-inch balsa wood stick, and it's to be cut into 2 pieces so that the longer piece is 3 times the shorter. Find the length of each piece. So we can start off by just writing 48 on one side of the equation. So let me explain why. So we have a measurement right here, 48 inches, and it's saying it's to be cut into two pieces. So this is telling us that if we add up those two pieces that are being cut, we should get a length of 48 inches. So this is why I'm writing 48 and then an equal sign. And then I'm moving on to the rest of the question, which says, so that the longer piece is 3 times the shorter. So we have two pieces. We have the big piece and we have the shorter piece. But we have that the big piece is going to be 3 times the shorter. So that means that the big piece is going to be 3 times s. So since we have 3 times s and s, we can now write that 48 is equal to 3s plus s. Okay, so I just want to make sure you followed. So we have the longer piece, which is 3 times the shorter. So b is equal to 3s, so we put that right there. And then we have to add that length to the shorter piece, which is just s. And now we should get 48. So when we do that, we have 48 is equal to, combining like terms, 4s. Then we multiply by 1/4 or divide by 4, whichever way you like to think of it. And then 48 divided by 4 is just 12. Now, this tells us the length of the smaller stick. But we're not done because we still need the length of the bigger stick. But remember that the bigger stick was equal to 3 times the length of the shorter stick. So we plug our variable s into this formula for the big stick, and we find b is equal to 3 times 12, which is equal to 36. Our last example for today's lecture is going to have to do with a question very similar to example 3, but in this case, they don't explicitly give you what all of the pieces is equal to. So right now, we're dealing with angles, and it says the second angle of a triangle measures 3 times as large as the first. Let me highlight that, 3 times as large as the first, and that's for the second angle. If the third angle measures 55 degrees more than the first, find the measures of each, or of all 3 angles. So let me highlight that in a different color. So now we have the second angle and the third angle, both in terms of the first angle. The question is, how many degrees should all of these angles add up to? The answer is 180 degrees. For all triangles, the sum of their angles is 180 degrees. So this isn't explicitly given in the problem, but it does talk about how these are all 3 angles of a triangle. Now, we'll do what we did for the last time. So let's call the first angle F, and let's call the second angle S, and the third angle T. So it says the second angle is 3 times as large as the first. So this means that S is equal to 3 times the first. And then it says the third angle measures 55 degrees more than the first. So this tells us that T is equal to F plus 55 degrees. And now again we have all of our angles in terms of 1, just like in the last example we had the bigger side in terms of the smaller side. So now that's what we're going to plug in to this equation. We're going to have 180 degrees is equal to F plus 3F plus F plus 55. I'm going to put parentheses to kind of highlight that this is the first angle, this is the second angle, and this is the third angle. Okay, so now we try to solve for F. And in order to solve for F, we have to combine all of these like terms, and we have to subtract 55 from both sides. So this is going to give us that on the left-hand side, we're going to have 125 degrees is equal to 5F. Using our multiplication rule, you multiply by 1 over 5, which gives us a solution f is equal to 25. Okay, so now we have the first angle. But again, we have to write this angle, we have to find the results of the second and third angle as well. Remember, we had s is equal to 3f, which is equal to plugging in our newly found f, 3 times 25. So f is going to be 75 degrees. I'm sorry, s is going to be 75 degrees. And lastly, we have t for our third angle. T is going to be equal to 25 degrees plus 55 degrees, which is equal to 80 degrees. And that is how we find all three angles in this problem.